With a yank, Bob Gore reenacts his famous experiment. Frustrated none of his previous plans had worked in producing what he wanted, Bob pulled on each end of the polytetrafluoroethylene, or PTFE rod, heated to 300 degrees centigrade, quickly jerking each side in the opposite direction, producing Gore's trademark ePTFE, or extended polytetrafluoroethylene, named for its stretched characteristics after being pulled by Gore. The remarkable polymer, called PTFE, commonly known as Teflon, formed an entirely new physical state, one which held the ability to be waterproof, breathable, biocompatible, and fire retardant, one which changed the world.
There's no place to run and no gasoline. Engine won't turn and the train won't leave. Engines won't turn and the train won't leave. I will stay with you tonight. Hold you close till the morning light. The morning watch the new day rise.
Bob Gore was born in Salt Lake City, Utah on April 15, 1937. His father, Bill, was a naturally curious experimenter. With a bachelor's degree in chemical engineering and a master's in physical chemistry, Bill Gore was bound for innovation. So much so that for a 1948 Boy Scout trip, he fashioned his own camping pack designed by his father and sewn by his mother. That same summer, when Bob was 11, his dad built a transparent plastic tent that the family used while camping in the mountains of Utah. Bill Gore entered the DuPont workforce after World War II at its Remington Arms plant in Ilion, New York. From there, he and his family moved to the DuPont experimental station in Wilmington, Delaware. In the spring of 1950, Bill and his wife Vive purchased 15 acres of farmland on Paper Mill Road in Newark, Delaware. Bill Gore decided that he would design his own house, act as his own contractor, and be a hands-on worker. Bob and his siblings helped in construction, Bob himself digging ditches for the electrical cables that would run to the house. After construction was underway, Bill, Vive, and their 5 children lived in the basement of their house for a year before it was fully completed. Bill thrived in his position at DuPont, but itched to make a living on his own. He found the idea that allowed him to branch out on his own in polytetrafluoroethylene, PTFE, a fluoropolymer discovered in 1938 by Henry Plunkett, a chemist who worked at DuPont, a great manufacturer of Teflon. PTFE is made of a carbon backbone chain that is protected by fluorine atoms which attach to it in one of the strongest bonds in chemistry. It is water-resistant, non-flammable, and has an excellent resistance to sunlight and weather. It possesses great thermal and chemical stability. It has a very low coefficient of friction and is biocompatible. Bill created a lab in his basement and commissioned a machine which he believed would allow him to create large sheets of PTFE. Bill and Vive would feed powder PTFE through a steamroller-like device, hoping to pull a creaseless sheet of PTFE out the other end. They shifted their plans towards insulating a series of parallel electrical wires by using PTFE. While visiting on vacation from university, Bob was let in on Bill's work, feeding powder through the rolls. The powder would pinch and crack, making the project unsuccessful. Bob suggested, why not take a thread sealant and feed it through the rolls? After being scoffed at and put to bed, Bob was awakened at 5 in the morning to the sound of success. The machine set up so the tape fed into the rolls. The pieces of Teflon would stick to each other, sealing the wires. At last, Bill and Vive found the success they were looking for and the success they needed to build their own company. Bill and Vive Gore began W.L. Gore & Associates January 1st, 1958, on their 23rd wedding anniversary. The Gore basement became an epicenter of ideas and innovation, as friends and family joined to help create a marketable product using cheap supplies that could be found in the kitchen. Bob Gore, on the other hand, still had his studies at the University of Delaware to complete. Bob Gore graduated with his bachelor's degree in chemical engineering at the University of Delaware in 1959. He then pursued his graduate studies at the University of Minnesota, earning a master's, then PhD in chemical engineering. While Bob finished his studies in Delaware, Gore Associates gained flight, moving his place of business to a new facility nearby. They promoted their line of cable products. The first big breakthrough for W.L. Gore & Associates came about because the city of Denver was installing a new citywide water system. They needed control cables that could be buried underground. Gore's Teflon multi-conductor signal cables were a perfect fit for the job. The city of Denver ordered miles to be buried underground. Joining W.L. Gore & Associates full-time in 1963, Bob Gore enjoyed the freedom of the business culture and working side by side with his mother and father. W.L. Gore & Associates was based on the idea of providing customized wire. As the computer age approached, the company was poised to make a significant impact. IBM decided to mass-produce a computer system, the IBM 360. Computers then, filled with cable upon cable, IBM went looking for a reputable and safe option of storing wires. Gore was their solution. Other industries found that Gore's wiring cables suited their needs, such as the U.S. Defense Department and the National Aeronautics and Space Administration. The earliest Gore space applications were on some of the Surveyor satellites, the first U.S. spacecraft to land safely on the moon. On July 21st, 1969, the company played a key part in history. When NASA's Apollo 11 landed on the moon, astronauts on the trip installed seismographic equipment connected to the lunar lander with a small, lightweight cable manufactured by Gore. While the company was proud of their achievements in space, they knew they could not stop there. Looking for a new endeavor, the company leaped at the chance for change, taking on the problem of creating new plumber's tape. But adding extra air to the ePTFE, it was not only lighter, but tighter. The finding gave way to one of Gore's biggest sectors, thread and clothing. Slowly pulling at the PTFE did not result in the light polymer he believed it would. Instead, break. In a last resort, he tugged at the rod in frustration. It worked. Bob's discovery of a high-strength, porous material polymer, ePTFE, was a transformative moment for the company. The new shapes ePTFE took at Gore were fiber, membranes, tubes, custom shapes. This resulted in numerous products, including electrical cables, medical implants, emergency membranes, and the smash hit Adventure Laminates. Raised by a backpacker and a backpacker himself, Bob spent most of his time developing the fabric business. In 1990, an international team traversing the continent of Antarctica demonstrated the superior performance of Gore Tex in their expedition. By 1994, almost all athletes at the Winter Olympics were wearing Gore Tex. As the Adventure Laminates proved themselves worthy of their names, the market was booming, and people realized the true genius of Gore Tex. Made out of 3 major textiles, Gore Tex's outerwear was typically made of the lining, the ePTFE membrane, and the outer material. What made this textile so amazing was its waterproof yet breathable ability. Gore Tex contains over 9 billion microscopic pores per square inch. These pores are 20,000 times smaller than a water droplet but 700 times larger than a water vapor molecule, making the Gore Tex membrane functionally waterproof, while at the same time allowing perspiration to escape from inside. From the freezing heights of a mountaintop to the heated clamor of an operation room, to every mundane activity in between, Gore Tex holds us together, the fabric of our life.